Hey, grade 5. One of the biggest jumps in difficulty in this year's math comes from the move to multi-digit multiplication. Now, in the past, you've multiplied 1, 2, or maybe even 3-digit numbers by a 1-digit number. This year, we start multiplying 2-digit numbers by other 2-digit numbers, and that can be a lot to wrap your head around. Now, in my class, we talk about 3 different methods that can help you to do this, and students are encouraged to choose a favorite and use it as much as they want. As such, I've made 3 different videos, one for each method. So pick the one you'd like, and we'll go from there. Good luck! This video is to review what some places and some teachers call the 4 small problems method. Now in my class, we like to call it pirate math, because step 1 is to draw what sort of looks like a pirate flag. It's actually very similar to the way that we do the standard algorithm, so it should be pretty comfortable for a lot of you people that are more traditionalists. But it's broken down into a couple of extra steps so that we can more clearly see the things that the standard algorithm hides behind the scenes. It can be nice for a student to see every part of a problem coming together, and it can help with understanding beyond, this method works, don't question it, do as I say. So I like it quite a bit. How does it actually work? Well, the first thing I need to do is recognize that no matter which way I'm solving these problems, they're all different ways of making sure that I'm multiplying each place of one number by each place of another number. Knowing this, pirate math begins with me drawing kind of a skull and crossbones series of arrows between all of my numbers. Let's see what that looks like. Now, for our pirate math method, I need to draw a frame that shows all of the small problems that are going to be happening in here, and that's where the name comes from. That frame sort of looks like a skull and crossbones. What I need to do is make sure that there's an arrow connecting each place in one number to each place in the other number. It looks sort of like this. My 1s need to be matched with my 1s. My 10s need to be matched with my 10s. The 1s from one number need to be matched with the 10s of another number, and vice versa. This gives us our little skull and crossbones frame, and it actually also outlines the 4 problems that we need to do to solve this. None of them require anything more than understanding how place value works and how to multiply your 1s tables up to your 9s tables. If you're locked in on that stuff, this is incredibly easy. Let's take a look, and I'll keep the color coding so we can go. My 1s problem is 7 times 6. Seven times 6 is 42. I know that just by knowing my times tables. Now I can tackle any of the other 3 problems that I want to in any order, as long as I make sure I do all 4 of them by the time I'm done. I'm going to do the 10s times 10s, just because. That means I've got 3 times 9. But I need to remember, this is not simply 3 times 9. These numbers are in the tens place. This is 30 times 90. Now that's the same as 3 times 9, except that it's got 2 zeros tagging along for me to remember. So my answer should be in the hundreds place. 3 times 9 is 27, and since it's in the hundreds, I've got 2 zeros behind it. 30 times 90 is 2,700. I've got 2 problems left to solve here. Let's do 3 times 6. Now, that's not 3, that's 30. 3 tens times 6, which means my answer will be in the tens place. Three times 6 is 18, so 30 times 6 is 18 tenths. 180. I've got only 1 problem left. That's my 9 times my 7. But again, not just 9. 9 tens, 90. 9 times 7, I know from knowing my times tables, is 63. So 9 tens times 7 is 63 tens, or 630. Once I've solved all of those problems, I just need to add all 4 of these up. Two plus 0 plus 0 plus 0 is 2 in my ones place. My tens are 4, 0, 8, and 3. Adding those up, I get 15. I carry my 100 over. Now in my hundreds, I've got 1, 7, 1, and 6. Altogether, weirdly, that also comes to 15. And in my thousands, I've got a 1 and I've got a 2, which comes to 3. 37 times 96 is 3,552. Review complete! Now, no matter which method you were watching today, I hope this has been a good refresher for you. Or if this was your first time checking out this method, I hope it was an enlightening experience for you. Multiplying larger numbers is one of the first times that students really stumble with their math, especially in grade 5. But none of it's actually that hard as long as you're comfortable with your 1 to 9 times tables and be careful to follow the steps properly. No matter what your method of choice is, I hope you're better equipped after this to tackle those larger problems. Good luck, guys. Have a productive day. Peace.